So we now come to our final lesson for Module 3. And this is now going to put everything that we've learned in the first 3 lessons into perspective as we combine the system into a radial graded system. So we start this off by showing the example that you have on this system. It's really a very simple system that you got, where you've got a supply source and you've got your load at D. Although you've got loads that are happening at your B and C, but your system really shows an end to point D. Therefore, we're given this, and they give you CTs that you get from between A and B, between B and C, and between C and D. And we're given what our loads that are experienced at all of those bus bars and the fault currents at those bus bars. So at the below, you are given that we assume an overload conditions of 105%. You assume a grading time of 0.35 seconds, and they say that you've got a TMS for our relay C, which is the relay closest to the end, where you see it's going to be equal to 0.2 for TMS. Then they say use your standard inverse curves to grade our relays. So the first one, they say, all right, calculate the plug setting of relay RC, RB, and RA. Then they say with a faulted bus C, calculate the operating time for the relay at C. So that means that it's going to be the one remote, okay, to that relay at C, because it's right next to, it's behind it. Then using the relay time for relay C and fault current at bus C, calculate the TMS settings that are going to be utilized for relay B. And then it says from relay B, so it does it for you in a step-by-step process, but in a test or an exam scenario, you wouldn't be given these steps to go by. They will give you the system as is, give you this given information up to the point where they say utilize your standard inverse curves, and then they would say calculate the settings for this system. Okay, and you would need to know that you need to do all of these steps in order to be able to achieve that. I hope we are clear, guys, that for now it's a step-by-step guide, but in a real exam or test scenario, it would be that system and we'll be saying calculate, or rather give me the setting for the system above. So here we are going to do our plug setting calculations first, where we're looking at the plug setting at your C, your B, and your A. And note how I name them. I name them according to furthest away from my source. So at RC, I've got my overload rating over my rated primary current of my CT times my secondary current, which is 1.05. They gave us 105% for overload. I multiplied by my 150. Where is my 150 on my system? Look again at your system. You will see that your 150 was the load that you are given a D. Because remember, this CT or this relay is looking at what is in front of it in this case, which is your D load. Okay, so that's that 150. Then I get the 0.63 amps, and I then go and work out my plug setting, which is my pickup current divided by my rated secondary CT. I times that by 100 and I get my 63%. I do the same thing for my RB, but I want you to just notice what my load now is. My load at RB is looking at the load in front of it, which is the load at C and the load at D. So hence I'm heading the 180 at C to the 150 that was at D. I get what my pickup current is, and I utilize that to calculate what my plug setting is going to be. Then on the last one, I go again and I look at my load again, okay, and here I need to add the load that was at B, which is 220. I get my pickup current and then I calculate my plug setting. So now, our second question said we were looking at this with the load at bus bar C. So I need to see what my operating time is for my relay C. In order for me to do this, I now say, all right, I've got my IR. And my IR is really my fault current in the relay coil, which is divided by my rated CT primary current times my pickup current over. And then in this case now is different because I'm looking at my fault being at C. So therefore, that fault current, I don't look at what was at D, but what is at C, which is going to be 6,000 amps. So it becomes my 6,000 divided by my 250 multiplied by my 0.63 that I got from my plug setting. I then go and calculate what the operating time is going to be because I already have a TMS over there, and I get 0.37 seconds. So that is the time that relay C will operate for a fault at C. And relay C is the one that is remote to that bus bar at C because it's just in front of it. Now this is where that total operating and grading was coming in. If I am now going to my relay B, then I need to say my total operating time for my relay B is going to be the operating time I just got at C, which was 0.37 seconds, and I add my grading margin, which was 0.35 that I've been given in the system. If I'm not given a grading margin in the system, I assume a 0.4 seconds. So I get that my total operating time for relay B is going to be 0.72. Okay, so remember now I need to work out what my TMS is going to be at B. So therefore, with the fault again, looking at RB and the fault at bus C, which is the 6,000 amps, and I've got a total operating time of the 0.72, I can go work out firstly what my IR is. And my IR, looking at that fault level, I divide by the 5,000, I multiply it by the 0.69, which was my pickup current that I got for my relay B. I get the IR is 17 point that, and then I can go and put it into that formula of T is equal to TMS times 1.014 over IR to the 0.02 minus 1, and I can work out then what my TMS is, and I get a 0.3 in this case. With the answer from my current slide, I can then be able to calculate what I have looking at B as a remote side fault, and I know that my fault current at B is 7,000 amps, and I know what my TMS is from what I've calculated. I can then work out what my IR is. With that IR, I then get the operating time of my relay B from the remote fault that it has got 0.68. I can then go and say that my total operating time for this relay is going to be equal to that T plus my grading, which is going to be the 0.68 I just got plus 0.35, which is going to be 1.03 seconds. I then go about and calculate what my IR is going to be at RA, looking at the fault that I have now in front of me, which is going to be at bus bar B. I calculate and I say I get 12.15. I then go and get what my TSAL value is going to be for that. I then move along and I can find that my grading needs to be tested if it can be able to function correctly for this purpose. I see that with my verification, if I have a fault at bus bar D and I want to see all of the three relays that they respond accordingly, and that there is a time lag between each of them for the same fault at bus bar D. I put in my IR for relay C, and then I do my time for relay C. I go to relay B, I put in my IR, I'm using the same fault that's at bus bar D now, because everyone is looking at bus bar D, and then I do my time. Then the last one I do for my relay A, and I do my time there. And I can clearly see that the time at relay C is the shortest time to clear the fault at D, and then it's followed by the time at relay B, which is followed by the time at relay A as the largest time. But I want you to also look at my IRs, okay? My current at A is the smallest current because I don't want to have all that inrush of fault current being seen by my source side. So I want that current to be suppressed by the time that it gets to my source. So it's smallest and it grows bigger when I get towards the fault area. So it's clear that the grading function is working very correctly, where I've got a delay between my C and my B for a fault at D, and there's a further delay between B and A for that same fault at D. Then I've got my discrimination with fuses, where it says if I have a system that has got a fuse in the system and relays, then the furthest relay can be set at 0.3 seconds, and this relay will then be able to discriminate with a fuse. The relay and the fuse discriminate only at a maximum fault level, not at other lower currents that you will get on your system. And in order to ensure that I've got a proper discrimination, I would usually put both my fuse and my relay curves onto a computer so that it can do a comparison for me to determine that they are really compatible and that the relay can be able to properly discriminate with it. If I see that there's no proper discrimination, then it means that the plug settings and the time multiplier settings of my relay would need to be changed. In this scenario, you usually find that it's best for us not to use the standard relay inverse, but rather to go for the vary or the extreme. And the computer will then determine for you what the new relay curve would and plot that curve or that graph for you. It determines you the settings in the shortest space times. This allows you not to have to go through multiples of settings trying to discriminate with the same fuse. We then have a system with a change in voltage bus levels where you can have a scenario of transformers that are within your system. And you can see that here you'll still follow what we have learned on your steps, starting furthest away from your source and then getting closer and closer to your source side. However, one of the differences is that your load, whereas in the previous example, we kept adding up our loads together, in this case, you don't. Each section, you assume that the load is within those two bus bars. Then the problem here arises when your curves of your relays are plotted to verify the discrimination between your relay. Then in order for you to overcome that, you need all of your currents to be referred to a common base voltage. Then you can be able to utilize the system better. Your standard IDMT relays are not suitable for this situation at all. But in this example, I've used exactly that because I want you to take the vary and the extremely inverse and utilize it, which will be part of your assignment too. So here we have a system, and this is our last one that we are going to look at in this lesson, where it's really a very huge system. You've got 5 bus bars in the system, and you've got 2 transformers. So your voltages are ranging from 132, then you've got some 11 kV, and then you have also some 3.3 kV. You also have a fuse that is right at the end of your system. They tell you that where you don't have transformers, that in those portions of your sections of network, you've got 390 amps as your cable size that you have. So that is really going to be your load that you get in there. we are not given anything that talks to our overload scenario. So we will utilize our full load current in all our calculations in this case. So we start this exercise by first saying if I'm looking at a fault at E, which is furthest away from my source area, it means that I must take that source, or rather that fault current, and transfer it to be a current that my relay can read at 11 kV. Then that means I take it, I use that base value, and I find 1873. So I've brought now that fault to be able to be read at 11 kV where my relay is sitting at. I work out my pickup current, which is my overload rating over my rated primary current of CT times my secondary. And therefore, in this case, I can clearly see that I don't have an overload condition given to me, but for my total rating or nominal rating, I use the 4 MVA divided by my voltage, not forgetting also the square root of 3, and therefore I get my 5.2. I can then take this and utilize it to get my plug setting, which will be 84% in this case. I then be able to calculate for my RD, my IR, and my IR I know I'm taking with the fault current that I got in the system, which is going to be that calculated fault current that I got of 1873.8. I divide by my CT times my plug setting, and then I can be able to get my 8.92. I take the 8.92 and I put it in the formula for my time, and I get my TMS value. The 0.3, remember, is the trip time on the relay that is discriminating with the fuse. So because my time setting was less than 0.1, I am going to utilize it or set it at 0.1 because that's my recommended start for my time setting. I then utilize this time setting in order for me to calculate the time that it would take for relay D to act on a fault at now D, which is the fault that is on the remote side of it. Okay, so I first start out by working what the IR is, looking at that fault current, and I don't have to bring it to any voltage because my relay and that bus bar are sitting at the same voltage. I find the time, which is 0.21 seconds. I come to my next one where now I can be able to look at my relay C. So for my relay C, I first do my pickup current and my plug setting. Once I have got those two, I can work out what my IR for it is. And remember, I'm looking at the bus bar in front of my C, which is the one at relay D still. I then can be able to say my total operating time is what I got in my previous slide. I add the 0.4 for grading because I wasn't given one, and I get the 0.61, which I then utilize to solve for my TMS. Once I've got the TMS, I can then look at my remote side of relay C, and my fault current there is the 6456. I find my IR, and I utilize that IR with the TMS that's calculated in order for me to find my operating time for my relay on my remote side. I then go on to my relay B. Now at relay B, I know that there is a transformer in the mess. So wait for it. The first part is for me to do my pickup current. So therefore, I utilize the transformer, which is the 30 MVA divided by the square root of 3 times my voltage. Okay, and that gives me what I would find as my pickup current. I take that, utilize it to work out my plug setting. Then I can now start saying I need to bring in my fault current at relay C, at bus bar C to be able to be read by my relay at B. That is now utilizing the base of 132 kV. I find that fault and I can go and work out what my IR is. Then I take my total operating time, which is the time that I just got previously, the 0.561, and I add the 0.4. I can then be able to calculate what my TMS is going to be in this scenario. Once I have my TMS, it means I can go to be able to look at my remote side of relay B. I look at my remote side. I don't have to bring anything on the current or fault current. I take it as it is. The 6736 to work out my IR. I then calculate what my time is going to be utilizing the TMS I just got. Then I can be finished now because I'm going to relay A. I've already done my remoted relay B. Remember that time in there. So I do my pickup here, and here I don't have a transformer, so my rating on that system is just at 390 because I also don't have an overload given to me. I work out my pickup current in my plug setting, and then I can go to my IR. So my IR is looking at the fault in front of me, which is the 18B at 6736, and I divide it according to my CT and my plug setting that I got. I then go and I utilize that to work out what my TMS is going to be. And that would be the end because I don't have to do my remote side if I don't have another CT that is going to be further uphill. So there is my settings table. I've got all my relays A, B, C, and D, and I've got my plug setting for each, and I've got my times multiplier setting for each. Thank you.